Good day, my name is Nicola, and in this video I will be explaining another partial differentiation example. This is the second example in a series of videos where I explain partial differentiation and how it can be different for different factors such as sine and cos or e to the power of x. So let's get into this example. Here we have fxy is equal to e to the power of 2x cosine y squared minus e to the power of y to the power of 2 sine 2x. And we are going to derive this in terms of x and in terms of y. But first I want to go through some of the rules that will be used in this differentiation that will help with deriving it in terms of x and y. These are quick rules that will help you derive functions faster. So first we have the derivative of j times x to the power of n, and that is equal to jn times x to the power of n minus 1. And in this case, j is any real number and n is an integer. And so when we're deriving j times x to the power of n, we can quickly derive that as jn times x to the power of n minus 1. Here we have the derivative of sine n times x, and so that is equal to cosine nx times the derivative of nx. This is a rule that you would need to be able to remember. So again, the derivative of sine nx is equal to cosine nx times the derivative of nx, where n is any real number. Continuing onward, we have the derivative of cosine nx. Again, this is another rule you would simply need to be able to remember. So we get negative sine nx times the derivative of nx. Alright, so the derivative of sine nx is equal to cosine times the derivative of nx, but the derivative of cosine nx is equal to negative sine times the derivative of nx. And if you're having a hard time understanding the rules while I'm explaining them, don't worry, these rules will all be applied to this differentiation example. And then here we simply have the derivative of a constant n, which is equal to 0, that you will remember from prior videos, that the constant, which is a real number that is not multiplied by x, will simply be derived to 0. And finally we have the derivative of e to the power of nx, derived in terms of x, and that is equal to e to the power of nx times the derivative of nx. So when it's e to the power of nx, we do not employ this power rule of n minus 1. We simply get e to the power of nx times the derivative of nx. Okay, so let's continue on with our example of deriving f in terms of x. We'll start with deriving f in terms of x. Alright, so first what we're going to do in applying these differentiation rules is we are going to put the terms that we can derive in brackets. So again, we're differentiating in terms of x, which means that cosine y squared will be treated like a coefficient that is multiplied by e to the power of 2x. Why? We are not deriving cosine y squared because that is not equal to x. We are only deriving x. And you'll remember here, when a number is multiplied by a value that is being derived, in this rule x, we simply multiply it by x. So cosine y squared over here acts like this value j over here, where it is simply multiplied by the derivative of our value that contains x, which is why we derive it like this, e to the power of 2x. You could, if you wanted to, include cosine y squared into this bracket, but again, it would just act in the same way as j does in this rule. So notice how j is multiplied by x to the power of n, and in the derivative, again, j is just multiplied by the result of n. So you just multiply cosine y by the derivative of e to the power of 2x. So that would apply for the same thing here in this rule. So if we were multiplying e to the power of nx by some integer that is represented as j, even in the derivative, it would just be j times e to the power of nx times the derivative of nx, which is why for convenience I have put cosine y squared on the outside. Because again, we're deriving in terms of x. So we are putting into brackets the parts that we will derive. Again, the same concept I explained for why we are putting cosine y squared on the outside over here can be applied to e to the power of y to the power of 2 over here. E to the power of y to the power of 2 is multiplied by sine 2x, as seen here. And so we are multiplying e to the power of y to the power of 2 by the derivative of sine 2x, because it is just the coefficient being multiplied by the value we are deriving. Okay, so continuing with the derivative of e to the power of 2x, we know from this rule over here, the derivative of e to the power of nx is equal to e to the power of nx times the derivative of the power nx. So we have this here, and we've rewritten the derivative of e to the power of 2x right over here in terms of its rule. Alright, so here we have e to the power of 2x, and that's the same, times the derivative of 2x. That's what we have right here. Okay, again, this is equal to this, as explained by the derivative rule for e to the power of nx. And let's also derive sine 2x. Again, we're going to apply the differentiation rule for sine nx. Okay, so the derivative of sine nx is equal to cosine nx times the derivative of nx. In our example, we have sine 2x. So the derivative of sine 2x is equal to cosine 2x. See that here? Cosine 2x times the derivative of 2x. Okay? You can see here, nx here, derivative of nx here, 2x here, derivative of 2x over here. Okay, so we've rewritten the equation in terms of the derivatives, and we can see that the derivative of 2x is over here and is over here. So we need to find the derivative of 2x because it's used twice, because we still have this derivative fraction both here and here. Okay, so breaking away from deriving fx for a moment, we are going to focus on deriving 2x. And I wrote here a little to the power of 1. This is for clarity when working with this rule for derivatives. This is for clarity, but usually you would not need to put the to the power of 1 over here. Okay? Right, so let's follow this rule over here. So the derivative of jx to the power of n is equal to j times n times x to the power of n minus 1. Okay, so in our case here, 2 is our j, and 1 is our n, and again, we just have x over here. So j times n, 2 times 1, and then we have to multiply 2 times 1 by x to the power of n minus 1. So again, our n over here is 1, so it just becomes 1 minus 1. So that is then x to the power of 0. And any number to the power of 0 is equal to 1. Okay, so it becomes 2 times 1, this 2 over here, this 1 over here, and this x to the power of 0 is equal to 1 again, so it's 2 times 1 times 1, which is simply 2. Okay, that's equal to 2. So that means in this function, this derivative of 2x, over here and over here, is equal to 2. So let's return to deriving our function in terms of x, and let's substitute the derivative of 2x with its value 2, which is done down here. So we've simply rewritten the equation, but replaced the derivative of 2x for its value 2. Okay, so here you can see 2 times e to the power of 2x, that's from here, times cosine y squared, again that's just from here, minus e to the power of y to the power of 2 times 2, that's from over here, times cosine 2x, that's from over here. So we can rearrange this equation so all of the terms are written in the same order of 2 times e to the power of 2x times cosine y squared minus 2 times e to the power of y to the power of 2 times cosine 2 squared. Okay, so see how it goes, integer e and then cosine. Alright, so that just helps with the clarity in understanding the variable. And both of these sides are multiplied by 2. So we can factor 2 out from each of these variables, which leads us with the final answer of 2 times open bracket e to the power of 2x times cosine y squared minus e to the power of y to the power of 2 times cosine 2x close bracket. That is our final answer for differentiating f in terms of x. Again, to reiterate, we are deriving f in terms of x. So we treat the other variable y as a constant. So here we have e to the power of 2x, so we are deriving that. So we're writing it in forms of derivation. Cosine y squared is being treated like a constant, so it is just multiplied by the derivative of e to the power of 2x minus e to the power of y to the power of 2. Again, we are treating y as a constant, and this value is multiplied by the derivative of sine 2x, which contains x, which we are differentiating. Right, so this is multiplied by this. We continue with our differentiating rules for e and our differentiating rules for sine. So e is over here, the rule for sine is over here. Okay, and we've applied that, and we recognize that the derivative of 2x is in both of these brackets. So we step away from deriving f in terms of x, and we differentiate 2x. We found that that is equal to 2, so we replace the derivative of 2x with 2. Okay, and after this we rewrite the equation. We've realized that both terms are divisible by 2, and so we get our final answer with 2 factored out. And that is the differentiation of f in terms of x. Okay, so let's continue on with differentiating f in terms of y. So here I've rewritten the function, and again we're differentiating f in terms of y. So we treat values with x as constants, because we're not differentiating x, we're differentiating y. So e to the power of 2x and sine 2x are treated like constants that are multiplied by the derivatives that we are figuring out. Okay? So we then have e to the power of 2x times the derivative of cosine y squared minus the derivative of e to the power of y to the power of 2 times sine 2x. And again, we're going to remember our rules for differentiation. We have the derivative of cosine y squared, and we have the derivative of e to the power of y squared. So the derivative of cosine y squared is equal to negative sine y squared times the derivative of y squared. Okay, again, the derivative of cosine y squared is equal to negative sine y squared times the derivative of y squared. Again, we get this from this rule over here. And I do know that in the rule it does not mention when a power is involved, but when there's like a power involved, just like y to the power of 2, you just include that over here, and we derive it as we normally would over here in deriving y squared. Okay, and then we follow our differentiation rule for e. So it's e to the power of y to the power of 2. Okay, so again, following this rule, we simply write e to the power of y to the power of 2 times the derivative of e's power over here. So e in this rule, e is to the power of nx. So the derivative is equal to e to the power of nx times the derivative of nx. So applying that over here, the derivative of e to the power of y to the power of 2 is equal to e to the power of y to the power of 2 times the derivative of y to the power of 2, because y to the power of 2 was the power of e over here. So the derivative is multiplying e to the power of y to the power of 2 times y to the power of 2. Okay, and that is multiplied by sine 2x, which is simply treated as a constant. Okay, and we can see in these boxes drawn over here that the derivative of y squared is in both of these brackets. Okay, so splitting out of deriving f in terms of y, you can find the derivative of y squared. And again, this follows the same rule for derivative of x written over here. Okay, so here, y is multiplied by an invisible 1, as all numbers are. Okay, so if we are applying jx to the power of n to this y squared over here, it would be 1 is our j, and then x is our y in this particular example, and then n is our 2. So the derivative of y squared, following this rule, would be equal to 1, because that's our coefficient of y squared. There's an invisible 1 multiplied by y squared, times 2, okay, because that is the power of y, times y to the power of 2 minus 1. Because, again, notice over here, we multiply j and n by x to the power of n minus 1. So here we multiply 1 times 2 by y to the power of 2 minus 1. Okay, so that then becomes equal to 2 times y to the power of 1, which is simply y. So that becomes 2y. The derivative of y squared is equal to 2y. Okay, so we put this value 2y into our brackets. So over here and over here. And rewriting it, we then get e to the power of 2x times open bracket minus sine y squared times open bracket negative sine y squared times 2y, again from this differentiation right here, minus open bracket e to the power of y squared times 2y. Again, because we derived y squared, got that the value is 2y, so that's written there. Then times sine 2x. So let's rewrite it in a way that's a bit clearer. We have negative 2y. Again, we get this negative from the negative sine y squared, and that's multiplied by all these variables. So it becomes negative 2y times e to the power of 2x times sine y squared minus 2y times e to the power of y to the power of 2 times sine 2x. Okay? And we can notice that both of these variables are divisible by negative 2y. Both have negative 2y here, they both have negative 2y here. Okay, so we can factor out negative 2y for our final answer, minus 2y times open bracket e to the power of 2x sine y squared minus e to the power of y to the power of 2 sine 2x, close bracket. And that is our final answer for differentiating f in terms of y. So in this example, we applied a lot of differentiation rules, which helped with partially differentiating the function a lot faster and making the process a lot easier for us. Okay? So I hope this video helped you understand partial differentiation as well as certain rules that will make your partial differentiation process easier and faster. If you like this video, please like it and consider subscribing for more content that explains calculus concepts.